Figure 8.11, printing a string one character at a time using a non-constant pointer to constant data. So in this example, for the first time, we're going to apply the const keyword to a pointer declaration and start to see how that affects our ability to manipulate that data. So what we have here is a print characters function that we'll be using that's going to walk through a C-style string one character at a time and display the character until we reach the terminating null character. Now for that purpose, we've declared that its parameter should be a pointer to a character constant. And if you think about it, a function that prints out or displays information should not need to modify the data that it's displaying. And that's what we're saying here. By declaring that the pointer is to a character constant, when this function receives the C-style string, it's going to treat the data as if it's constant, thus allowing us only to look at the data, not modify it. And this is really more of an issue of protecting ourselves at compile time so that we make sure in the body of the print characters function that we don't modify any of the data. If we did, we would then get a compilation error. So you can see here that print characters receives a pointer called sptr that points to a character constant as far as it's concerned. It points to the first character in an array of characters that represents a string. We're going to call it phrase. And in the loop, we have a little for loop here that has an empty initializer section because the s-pointer variable has already been initialized by calling the function. And our condition is to keep iterating as long as the dereferenced pointer, which is one of the characters in the string, is not equal to the null character. If that's true, we will display that one character, and then we will increment the pointer to move to the next character in the string. So a similar processing to what we did in the last program, but this time we're simply outputting a value. And of course, when you output a value, it does not modify that value. Therefore, in order to implement what you might call the principle of least privilege, we use the const keyword applied to our pointer here, saying that the pointer is pointing to a character constant, therefore we cannot modify that data. If we left off the const keyword here, the function would still work the same way. The problem is that we could accidentally write code in the body of this function that would modify the data, and we want to prevent that as much as we possibly can. So anytime you have data that should not be modified, you're typically going to want to be using the const keyword. So if you look at main here, we have our simple phrase. It's a constant character array this time that contains the string print characters of a string. And in line 15, we pass that phrase array to the print characters function, and if we stop there and run this program, we can see that it is indeed able to display all of the characters in our string, and we did it one character at a time in this case. And of course, you probably wouldn't do that normally. We're doing it for demonstration purposes here. Now, what if we did try to modify the data inside of a function like print characters? Well, for that purpose, let's take a look at the next figure, which is figure 8.12. And in that one, we're purposely going to cause a compilation error. So here we have a mechanical example just to demonstrate the error that occurs at compilation time. So we have a function called f that expects to receive a constant int star, or a pointer to an integer constant. And that function, as you can see down here, also is declared that x pointer is a pointer to an integer constant, yet we are trying to modify the value in memory by dereferencing the pointer and assigning 100. Now, when we do this, if we try to compile the project, let me go ahead and say build solution, you can see here that we get an error message, xptr, you cannot assign to a variable that is const. Well, if we go back to our code here, the expression star xptr, if we take that, remember how I told you that you can read your declarations of pointers a couple different ways. We can say that xptr is a pointer to an integer constant, or we can say that star xptr is an integer constant. An integer constant is an integer that cannot be modified. So when you try to say take this expression that represents an integer constant and modify it, you then get a compilation error. So by applying the const keyword on the left side of an asterisk, in a pointer declaration, you are saying that the data that the pointer points to is considered to be constant and therefore cannot be modified. So that's a way of protecting the data that's being passed into the function to guarantee that it won't be modified in the function's body. And the reason that we can guarantee that is because if you try to modify the variable, the pointer, as we did here, rather not the pointer, but what the pointer points to, you will get a compilation error. In the next video, we'll look at some more uses of const with pointers.